Hello everyone, are you able to hear me clearly? Hi Anand, hi Carlos, hi Zuan, hi Kamal, hello Pankaj, hello Peter, hello Rohit, hello Xiao, hello Srini. Alright, alright, so where were we till the last time? We had discussed this particular problem and we were about to move to the next one, right? So do you have any questions before we start? Alright. Anand is saying, Anand, can you try without HTTP? Because it is the HTTPS which may not be working. Alright. So try HTTP. Alright. So, okay. Alright. So one question from Zuan is that could you make a basic review? Alright. So far we have discussed few things. One is that we discussed in the first session is about HDFS, where we divided the data onto multiple machines. And now, by the way of MapReduce, we are trying to run our logic on multiple machines. So earlier we talked about dividing this work on multiple storages, and now we're trying to get our work done by using multiple machine. And by using multiple machines, we get an added advantage of data locality because data is also located on multiple machines. Now the question arises that if you have logic divided on multiple machine, how do you how do you build such a logic which can run parallelly on multiple machines, right? And that's where the MapReduce comes into play. And in MapReduce, we create two parts of logic. One is map, other is reduce. The map logic runs on every machine, translating the input into key value pair. Okay, which means no matter what is the input, where is your map logic is going to run, it's going to try to convert every input record into key value. All right. So we ourselves are not trying to read the file directly. Hadoop is reading the file, reading the data, converting the input blocks into records. On each record, our map logic is being called. And on each record, when the map logic is being called, it's generating key value pair. And based on that key value pair, it groups the data. All right. So that was our MapReduce logic. That's what we have done so far. So using so many machines, while we can have big storage, we can also have big computing on top of all of this data. All right, is that good enough, Zuan? Yes, Pankaj. I will explain MapReduce program using Java, and we'll also explain how to execute it. All right. All right. There is a question from Srini. Okay. That this one is this particular command is giving error. All right. So yes, of course this command will give error because it will try to read the full directory structure, and not it will basically try to access everything. Therefore, what you do is you try to redirect the error output to dev null. Okay, you basically don't want to see the error messages, and this part of the command does exactly that. It redirects the data from the error from to dev null. All right. Another question from Srini is, after more command, what is command to command prompt? Okay, you can just press Control C. Okay, or you can say only Q. You just enter Q. Is that what you're looking for, Srini? All right. All right. So, okay. Let me pick up the next question from Rohit. Rohit says that in Hadoop streaming command, do we have to specify a path under this? Okay. Good question. Good question. Can anybody suggest what would be the answer? All right. So here's a question from Anand. In Hadoop streaming, the command, do we need to specify a path under this? Not necessarily. So this is a relative path. Okay. So this is a relative path in which it does not have to start with slash. Okay. So either you could give a absolute path like um, let's say, what is my folder name? My folder name is, let's say, home. Okay, and we say my cmd.sh. Or if we are in this folder itself, if our present working directory is this, then we can also say this. Or we could say dot slash. All right, either of these is fine. So this, this. Okay. The other way could be that if we are, this is our home folder, we could just put a tilde. Tilde represents for home folder. So all of these are kind of equivalent. All right. Now that was first part. Now, Rohit's question is, where do we define this setting? Actually, this is from the the MapReduce Java part. Okay, Java part. There is an equivalent. There is an equivalent in Hadoop streaming. Okay, so in Hadoop streaming, there must be a parameter which does the same thing. Okay, let me have a look at what does Hadoop streaming provide. Looks like mapper does not have, we cannot specify mapper using streaming. Yeah, you can specify. All right, good. All right, let me just change it. Using this. All right. All right. Now, Srini's question is this. I think this got answered earlier when we talked about this. All right. So, Pankaj's question, yes, today. All right. All right. So, Anand is saying yesterday he got the resource manager error and could not execute the code. It tried to start the job in every few seconds but returned failed. System tried around 50 times automatically but came out. All right. This sounds like if it tried for 50 times, then This is interesting because internally, when a MapReduce job is run, it hardly tries for 3 to 4 times. Okay, so if it tried for 50 times, maybe there's an error in your map function. Could you? So, which command did you try to execute, Anand? So you just send me an email with the command you try to execute, and let me see what exactly is. Okay, okay, he tried to execute the same what we saw in the last class. Interesting, interesting. Did it run now? All right, let me have a look. You tried to execute it again. All right. All right. So we were about to do the discussion. All right. So the earlier problems are clear to everyone. These problems related to the DNA. Yes. Anand's question is, shall we download these documents? It is up to you. As long as you don't upload in public, we are okay with you downloading this. All right. Yes, Peter, are you able to hear clearly now? All right. So this problem is clear to everyone. Should we proceed further? All right. All right. So the to do for me is upload the class notes. All right. Thank you, Srini. Let me get it done. Great. So let's start with the discussion further. So this voting problem is clear to everyone. Did anybody think about a solution? Yes. So in this unusual democracy where everyone is not equal, the vote count is a function of worth of the voter. What would be the vote count of what would be the end result of these two lists? What will be the vote count of each votee? Anyone? All right. So Zuan, no worries, no worries. If you missed the class, and did you go through the video? All right. So anybody has a suggestion here? So how would you do this? So there are a few things you should keep in mind. One, list one and list two can be concatenated by feeding both of them to the mapper. If we are running our Hadoop program, we can put both of them into a folder and then feed that to our MapReduce program. That's how we can concatenate the two. Yes, everyone? So has anybody tried to solve this fourth problem? I think we discussed all other three problems, right? All other problems, including 3A, 3B, second, and first. Yeah? Carlos, Kamal, Pankaj, Peter, Rohit, Xiao, Srini, Sumati. Did we discuss the other problems, right? In detail? Did you think over this particular problem? All right, all right. So let me repeat the question and then we will go into the solution. If you have a solution, if you have thought about it, you can write it down right away. So in this unusual democracy, the people are not equal and their vote counts do not is not equal. Their vote counts is a function of their bank balance or their bank account worth. So we've got two lists. One is who voted for who, and second is who has got how much worth. Interestingly, this problem is the one which actually is very close to PageRank. And PageRank is the algorithm with which the Google started their search engine. So that was the key algorithm and key insight into the search results. All right. Peter says take the values of each key and assign worth of the voter to each of the votees. Interesting. Interesting. Pankaj says keep the key as votee. All right. All right. So Okay, so for those who are not, who did not go through this problem of the last week, here let me repeat. So here, this first list says voter and votee. Second list says how much is the worth of each of the persons. Now, when A has voted for C, okay, so C's vote count because of A has become 5. Now, when B has voted for C, B has gained a worth of 1. Okay. Therefore, and here F has also voted for C. Okay. Now, there is no worth given of F, so we are assuming that to be 0. So, effectively, C was voted by A and B and F. F's worth we are assuming to be 0. Therefore, C has got 5 plus 1, A plus B. Okay. And F has been voted by C. So F's worth will be F's worth will be 11, and B has been voted by only A. So B's worth will be 5. Alright. So this is how the computation has happened. While nobody has voted for A, so A's vote count is 0. Yes. Carlos says that merge the two file first. Okay, that's correct. Okay. Alright. Harita says that alright. Good. Good. Keep going. Keep going. It need for a little bit more detailing than specifying. Okay. Yes. Yes. Peter, you are quite close. You're quite close. Yes. All right. All right. Okay. So here is what Peter has to say. Okay. And this is from Harita. This is from Harita. Okay. First map reduce key as votee and value as voter. The result set is then passed to MapReduce with second file. Very good. Okay. All right. So say okay. Well, let's okay in reduce. All right. All right. You're in the right direction. Yeah. Yeah, anybody else? So let's first gather the votees and the worth of the voter. Let's group the two files. Let's co-group them. Let's join and group together by the voter. Okay. So here is one of the approaches. Here is one of the approaches, and what we have done is these two lists we have fed to our mapper. And when we feed the two files to our mapper by the way of putting them into a folder or by passing them as comma separated, either way we can basically pass multiple files as input. And when that happens, these two files are considered as if they are a single file. And afterwards, you can simply, if we just print the first column as the key and the second column as the value, we will get all the votees and worth together for each voter. So for each voter, which is the key, the value, the worth of the voter and the name of the votees have come together. So A, whose worth is 5, has voted for B and C, while B, whose worth is 1, has voted for C. C, whose worth is 11, has voted for F. D, whose worth is 12, has not voted for anybody. F, who has voted for C, does not have a worth here, right? So now you can see that all this has come together. So this statement says that because A voted for B and C, B will get 5 and C will get 5. And that's what we have written here. We are saying as part of our reduce, we are generating key value. Or if we don't generate it now, then we'll have to generate it in the next phase of MapReduce. So there are two phases of MapReduce. One ends up to here. You see the line here. One ends up to here. We increase this line. All right. All right. So here you can see that when you run reduce, it will lead to this. So B gained 5, C gained 5, A gained 0 because of this. Okay, we are putting 0 here, although it looks like unnecessarily. Okay, we are just making sure that it reaches the output. All right. So you can also simply say as in like this. All right, like this. We are just putting 0 just to keep a 0 in the output. Never mind. So here you can see that A voted for B and C, because of which B gained these values. Okay. Now this key value could be the input for the next MapReduce phase. All right. And this generation of key value could also had happened in the map phase of next MapReduce. All right. And therefore, when Hadoop tries to group it, the next phase in the next phase, when Hadoop tries to group it, all the values for each key would come together. All the values for each key would come together. Make sense to you? No? And therefore, so for B, when the grouping would happen. So B might be gaining the value because somebody else also voted, right? Or C might be gaining value because somebody else might have voted. So C gained value because A has voted and A's worth is 5. So C has got 5 due to this. And somebody else voted by might have voted for B, and therefore C would get this. So if we group this particular output by the votees, then their worth will come together, and then we can simply sum it up in the reduce phase, right? And that's what is happening here. All right. Is the approach clear to everyone? So all the words of B has come together here, C has come together, F has come together. In the reduce phase, we have summed it up and we get the overall votes of each individual. So there are two things which we need to note here. First, we have concatenated the two files. Second, we have used two MapReduce phases. Hi Shashi. All right. So by chaining the two MapReduce processes, we are able to reach to the output. Also, please note that in the output of the MapReduce phase actually is saved in the HDFS. So this file is going to be saved in HDFS, and then we will run this second MapReduce phase from here as if it's a fresh MapReduce, just that the input of this one is from the previous MapReduce phase. All right. So there's a question from Pankaj. Pankaj says, so if I understood correctly, both the files will be passed as input to the MapReduce framework. That's correct. That's correct. And then when merging of the file will then where merging will so merging is done by the client itself. Well, merging means essentially considering both the files as part of the single input split. Okay, so all the blocks for each file will be located on top of which records will be created, and on top of records your mapper function will be run. All right. So this is a part of MapReduce framework, and you don't uh, okay you don't write that logic in your mapper function. Okay, you don't try to concatenate the two files by yourself, because most often these files are really huge and it doesn't make sense to concatenate them programmatically. All right. So here is the question from Harita. All right. Harita's question is, can we run the first map reduce on voter and votee and then merge the result set with the other file and then pass to the second round of map reduce? Can we first run map reduce on voter and votee? Okay. And then merge the result set with the other file. Okay. So let's see what is she trying to say. So what is she trying to say is, let's first merge these two. Okay. Okay. That's interesting. So what is she suggesting is, in case of first map reduce, let's just merge this. And I mean, let's just group it by the voter. And once we get these two together, then we can merge the result with the worth by joining that, by passing the two files together. That approach is also correct. That approach is also correct. All right. That approach is absolutely correct. And then in the second map reduce phase, we will just try to bring the votees together. Here I've tried to do multiple things in a single shot. Okay, we have tried to do something called co-group in this mapper phase. All right, so this is not the only solution, Haita, you are right. You can actually first group it and then concatenate it. All right, and then you can run the process again. All right, this question from Rohit. How is the second? All right, so this was the question from. All right, this is correct. This is correct. So Rohit says how second mapper is called. This mapper, this phase, it will be called by you only. You will have to run it by yourself. Okay. There are tools. We will this process of running two map reduce processes back to back is called chaining, and chaining is something which we will discuss in detail after some time. All right. So Pankaj's question is, so where will be merging logic configured? I mean, how Hadoop will come to know how file has to be merged? I mean, merged file will have 3 columns or 4 columns. All right. So this is interesting question. So the way it will happen is they'll just append to one after another. The way you can think of it is as if the file has been appended one after another. But in reality, what would happen is both the files, it will take both the files and then it will try to prepare, will try to prepare the records out of each file separately and then run your program on each record. All right. So first it will find basically for each file it will try to find out where are the blocks. Then on each blocks it will try to run your code. All right. So it will to you it will look like as if the two files has been concatenated or appended. So second file has been appended at the end of the first file. Sounds good to you? All right. So we have concatenated list 1 and list 2, and concatenating is very straightforward in MapReduce. All you need to do is either put them in a folder, pass the folder to the system, or you just pass the two files to the system. Okay. Both map streaming as well as Java MapReduce both provide this functionality. So you concatenate the two files and the grouping will happen on the key, which is voter on both the sides. And once that is done, it will once the mapper receives it, it is going to just do nothing but key value pair. So and Hadoop will take those values, group it together by key, and all the votees and their worth will become together. All the votees and the worth of the voter will come together. So effectively, this is what we get. The worth of the voter, which is A, along with the people who A voted for, has come together, right? And now What can we do about it? What can we do with this? We can basically say that due to this particular row, what is the gain in the vote count of B and C? The gain in the vote, because A has voted for B and C, and A's worth is 5. So B will get 5, C will get 5. Similarly, if there are more people voting for B and C, if there are more people voting for B and C, then that worth need to be also counted, right? Therefore, we can create another MapReduce phase such that we list down key as the people who got voted and the gain in the vote count. So we say B5, C5, A0 because in this particular transaction, A does not get any value. All right. Similarly, C got voted by B and C's gain in the vote count is 1. So if we group it by this particular column and then sum up their values, then you will get the vote count. That's what we are trying to do. First, we brought the worth of the voter together with all the people who this voter had voted, and then listed down how much is the increase in the vote count due to each of the voters. That's what we have done in these two phases of MapReduce. All right. Does it make sense, Shashina? All right. Any questions here, or should we move forward? All right. So this HDP arrow shows that here it shows that the internals of Hadoop is doing the grouping for you. Okay, here basically Hadoop has taken the input from you here. After mapper has given key value pair, Hadoop is trying to group the data by the key. Hadoop is trying to group and sort the data by the key. That's what this arrow represents. Okay, here in the second phase, there is no mapper as such because the output is ready to be consumed. It's tab separated, so even if there is no mapper, it will take it as if uh, the key values are already prepared. Great, great. I'm happy that is clear to everyone. All right. So, should we move forward? All right. All right. So before you think that the MapReduce is a solution to every problem, and before we feel that MapReduce is the meaning of life and everything, so let's be very clear that there are limitations to what MapReduce can do and where we should be using MapReduce. We should not be using MapReduce everywhere. So here are a few things, and this is a very important aspect. And since we come from the programming background where we do things as part of frameworks, good practice, and to stay cool, we do a lot of things eh, eh, because of our various reasons. So most of us think that the map reduce is a kind of a pattern, kind of a way to solve every problem. So it is not. It is only for the cases where you cannot get the work done by a single CPU. Okay, if you are happy with your single machine, if your work is getting done in a reasonable amount of time, then get it done using a single machine. Don't try to unnecessarily use MapReduce in those cases. Don't use MapReduce if your work is being done in reasonable time on a single machine. All right. Second, also, I'm adding to the first point that in case you foresee that after few months down the line the data is going to go beyond a certain size which cannot be handled by single machine, then you should go for MapReduce. Second, when your computation depends on previously computed step. So if you notice closely whatever we did earlier, our map functions can execute parallelly on all the nodes, okay? And also on the same machine, there could be multiple map tasks running parallelly, right? Which means that if they try to coordinate with each other, they will become sequential and it will become very slow if they try to use each other's output. So map functions are generally executed parallelly. They are not they are not generally sequential, which means one map function does not take input from another map. When the map is being executed, when map is being executed on one machine, the other machine, it won't wait for maps output of another machine. They're all being executed parallelly. The only way they can talk to each other is by the way of some central agency, right? Some central agency which we call global state or some other way. And if they try to access this global state and try to get the output from another map and take the decision based on it, it is going to be a big disaster. It requires enormous amount of effort for one map to talk to another map, right? Maps are supposed to be executed in parallel. So keep that in mind. When the computation depends on previously computed values, it doesn't make sense to use MapReduce. Okay? Specifically, I mean, look at the cases like Fibonacci series. In case of Fibonacci series, a value, a particular value in this series is equal to the summation of previous two values. Okay? So we cannot compute a series like Fibonacci because in Fibonacci series you are depending on other Fibonacci executions. All right. So Fibonacci cannot be divided into other ways. But if you are say computing the squares of natural numbers, your series says that you're computing squares of natural numbers, right? 1, 4, 9, 16, 25, 36, 49, and 64, 81, and 100. That kind of series, if you're running, you can actually cleverly do is you can divide your maps such that one one machine is computing the squares of the series from 1 to something, and the second machine is computing from say 100 to 200. Third one is computing from 200 to onwards. So you can compute such kind of series like computing squares, but because one is not depending on previously computed values. All right. So third is real-time responses. Since the way MapReduce has been designed is for batch processes because it utilizes the disk. So as you saw in the previous question, the way MapReduce first phase and second phase communicated was very strange. First phase put the data into the disk, and second phase read the data from the disk and utilized it. When this happens, the whole process is extremely slow because The disk itself is slow. So the IOs are generally fairly slow. And when you're talking about HDFS will be, each read will be slower than the normal disk, because HDFS involves a network call, and at the end of the day in HDFS also the data is read from the disk. Okay, so therefore the whole MapReduce framework has got a latency, has got a considerable latency. Therefore, the real it is not suitable for real-time computation. Okay, so the way MapReduce has been designed up is, it is for mammoth amount of data. MapReduce has been designed for mammoth amount of data and resilience, as in case half of the machines are dead, still things might work pretty well. Okay, or one of the machine died while you were executing, it will execute it on another machine. So by design, the MapReduce framework has been done for humongous data, as in humongous data in hundreds of petabytes of data, and and it has been designed to take care of the various problems while execution. If some of the machines are dead while executing, it will still get it done. All right, so these kind of design choices, these are the design choices which people at Google and people who created Hadoop took. So not Hadoop as in who created MapReduce, they took these kind of design choices, and therefore it's not suitable for real-time response. When the algorithms depend on global state, this we have already discussed. So if your algorithms which is being run as part of map or part of reduce, if they are depending on a global state, imagine your mapper code making a call to MySQL. So for each row or for each record or for each line in the input, there will be a network call. There'll be a network call to this service. And please note that in map or reduce, you can do anything. Okay, as part of map program, while it only gives out key value, but it can do a lot of churning. It can talk to database, it can talk to message queue, it can talk to, it can send emails, it can read from file, it can read from HDF, it can do anything what a program can do. All right, therefore if you try to access as part of the map program, if you try to access the some global data set, a global state, it's going to be humongously slow. All right. There is a question from Anand. I'll try to address this question. It's a very important question. So Anand says that during a proof of concept in my office couple of months back, MapReduce was used, but now Cloudera states that MapReduce is outdated and no more support in near future, and asked us to rewrite this stuff in Spark. Is this the case? In no. So I doubt. So MapReduce is not outdated. All right, MapReduce is not outdated. Okay, though the things have moved to Spark. Most of the things that have moved to Spark are those that want to exploit the RAM in order to make the computation faster. So for lots of practical purposes, you will be using Spark, but but MapReduce is not really outdated. Okay, MapReduce is not really outdated. It's being used. It has its own benefits over things like Spark. All right. Also, so nothing to worry on these fronts. We will go into a considerable detail into Spark. All right. So nothing to worry. And the good part is when you have clear thoughts on MapReduce, you will be able to sail through Spark really well, because the in Spark the whole paradigm is very close to or very similar to MapReduce. All right, great. Thank you too for bringing it up, Anand. So there is still a support. It is not out of support. All right. Now, while testing MapReduce, there are a few thumb rules that you need to follow. First is that you test on a small data. You test on small data, and when you generate small data, use random sampling. So the way I generally do it is take my data set, generate around 10 random samples, and we try to run my MapReduce on these 10 random samples and then see the result. So you test your program on the random samples of the data, because I have seen quite often that people try to take like first 20 lines and then try to run MapReduce on that, test it. But while they put it in production, what happens is those 10 lines, the first 10 lines were no way representative of entire data set, because though initially the beginning lines or the lines which come together, the you can be, there could be problems with that small set. You may not get the picture of the whole data. Now, second part is you always test your mapper and reducer separately. Okay. Third is the streaming jobs mapper. The mapper and reducer of the streaming job could be easily tested. A simple sort command like this. You can see that we are saying, instead of handing over to streaming, we are saying cat input, give it to mapper, and mapper gives to sort command sorts the keys, and then reducer will reduce it. So you can see that since streaming job does not group the data, therefore your mapper and reducer can be used as if they are part of the Unix commands. Okay. So that is the biggest advantage of coding in streaming job, that you can very quickly test your mapper and reducer. Okay. And this is something which I personally like, because I'm able to quickly test my mapper and reducer by the way of executing such kind of command. Fourth is that in case of Java, we will use MR unit. We will talk about it soon. And to test predictions, there is another problem called prediction. So mostly you will notice that in MapReduce, as part of MapReduce programs, you will be doing predictions. Okay, if you are doing predictions and you try to test it, so predictions by definition are something about the future, right? So how do you test such kind of predictions? So the general way is you split the data into two parts. One against which you will generate the predictions, and second against which you will compare the predictions. Okay. And if it is time based data, as in what did you like in history, based on which we are trying to compare your future choices, right? It's better we depend upon the timeline. So it's better we split the data based on the time. So for last year, we kept in one file. For this year, we kept in another file. Based on the last year's data, we did the prediction. We compared those predictions against this year's prediction. Okay. So that is exactly what I'm trying to say here. So to test predictions, you split the data into parts chronologically, into two parts chronologically, as in we split the data into last year and this year. Okay. Also, generally the way people split this data in into two parts is kind of 80/20. On 80/20 data, you will try to do the predictions, and for remaining 20% of data, you'll compare your predictions. Okay. Or let me try to take a very concrete example here. Let's say we are trying to give a recommendation of a product for products like Amazon. Okay, and how do we do that? We do that by knowing your preferences last earlier. So the way to test such kind of program is we split the data into two parts, saying all the data up to 2005 December 31st. That is one file, and the other data is other uh, other data is for this year, right? Now, and what is this data? This data is which product, how much did you like this product? Okay. So user ID, product ID, and the rating is what it is. So based on all of the data up to 2014, we'll generate the predictions. Then we'll compare that based on the history. We were predicting that you will like these products. Did you really like these products? Okay. And and the comparison of predictions against the second set can be done using the summation of differences. Okay, summation of the deviations. The way we compute standard deviation, we can do the same way. All right. I hope I was able to explain how do you do the predictions. All right. So whatever problems we have talked about so far, please code all of those in your own favorite language. Create the project on GitHub with your code and mention nobigdata.com in the readme.md. Okay, so who is not aware about GitHub? So you could go to GitHub. Okay, create a project. Once you log in, you can create a new repository, give it a name, say maybe with the name of no big data or something, and put some description and create the repository, and then you can start. You check out this repository and commit to it and then publish it. Okay. So why am I insisting on putting it on GitHub? Because GitHub is something which is a representative of your programming skill. Okay. So if you put your code on GitHub, you become visible to many people, and that actually helps in your career. All right. So try to create a GitHub project and try to push the code. Do not be ashamed of bad code or anything. Just publish the code on GitHub. Okay. It's completely okay. It's completely okay because that gives you the visibility. Sounds good to you? All right. So second assignment to all of you is based on the content of very large text archive form the words recommendation. Okay, meaning, so when you use Android phone or any other phone, so while typing you get these recommendations saying you may also like this, right? You may also like this, you may also like that kind of recommendations. Sorry, let me reiterate what I'm trying to say. Let's say I'm composing a message to you and I type happy. So you will see just above the keyboard, you will see the various suggestions after the keyword called happy. Okay, for me it's giving, let me just check. Okay, when I say happy, so it says happy birthday. So there are three suggestions I see on my keyboard. Okay, first is birthday, second is to, and third is new. Okay, and so if you have to generate such kind of recommendation, what will you do? All right, is the problem statement clear to you? And so the hint is that you can use the data from Wikipedia to do this. Okay, can we do this using MapReduce? And if you feel that MapReduce is not right way to do this, let me know. Okay, the idea is only generation of key and these values, not the UI, not the API, but kind of these three words follow this word. A big file containing a word and all the three words that are following, all the five words that are following a particular one. Okay. So Peter's question is, we have used Unix to run MapReduce. Are there similar executable allowed for running Python and all? Yes, definitely. Whatever we did for shell, you can do the same thing for Python. All right. There's nothing special about running using Python because you can just read from the standard input and print the output to the standard output. Same Hadoop streaming could be used with any program, any binary. Right? The only difference is in case of Java, although we can run our Java program as part of streaming, but it is also possible to write in detail the Java MapReduce code. So Dilshad's question is, what problems do we need to code? Are you referring to assignments from 1 to 4? Yes, all 1 to 5. And if possible, do the last one also. Okay, so whatever code you have to write, you can create a single repository, put all of the code in that single repository. Right? The other benefit of using GitHub is I can quickly edit your code and let you know that these are the suggestions you need to look at. So the code review becomes really good, and it becomes like in organizations. In organizations, when you work on something, you generally commit to the repository, and I check it out and then put my comments and send you a merge request saying, hey, these are my comments. All right. So that's how that's the biggest advantage of using such tools. All right. So Anand is hearing a lot of echo. Are you hearing a lot of echo? Okay, okay. Actually, I think my headphone got pulled out from my desktop, and that's why the there was an echo temporarily. All right. So this second number problem assignment second is clear to everyone, or let's just put it three. Okay, top three recommendations. Okay, you can ask if you have a doubt with this problem. Great. So think about this problem and try to solve it. Okay, try to solve it, even if you have to just fake the data, as in even if you have just small data, or maybe you can use big.txt for now and then run the same thing on the text from Wikipedia. There are many sources to download the text from Wikipedia. All right, you can run on that. I'll see if I can push this data somewhere on our in our slash data SDFS. All right. So that was basic understanding of MapReduce. We went into the details of MapReduce. We tried to solve multiple problems using MapReduce. We also covered what is right or what is wrong. Now we will start with Hadoop MapReduce with Java. All right. Now we'll start with Hadoop MapReduce with Java. All right. All right. So here is a quick quiz to all of you. All right. So the data generated by mapper is given to reducer and then is sorted or shuffled. Is that yes or no? Quickly. Pankaj, are you sure? Yes, you're right. Therefore, the answer is correct. Correct. So yes, the answer is no. The output of the mapper first goes to sorted and shuffled and then reducers are called. Alright? Brilliant. Okay. Now the question to all of you is the mapper can only generate a single key value pair for an input record. Input record in our case of word count problems was the full line. Okay. So far we have dealt with the text file containing lines and each line was the input to our mapper function. So can mapper only generate one key value pair? Rohit, is that yes? Is that true or false? Yeah, that's correct. It's false. Okay, mapper can generate as many key value pairs as it wants. You remember in our word count problems, we generated one key for each word. Okay, so each record got converted into many key values. Sounds good. Now here is a little tongue twister. Now the question is, a mapper always have to generate at least a key value pair. A mapper always have to generate at least one key value pair. Correct or wrong? Anyone? So okay, let me repeat again. When we were churning our word count input, the big.txt, what happens in the case where there is only blank line? Do we need to generate the key value pair for the blank lines? If a record that has come to you is just spaces, right? Do you always have to generate a key value in that case also? Or can you skip it? Can you skip that line? Yes, we can skip, which means that it does not always have to generate a key value pair. It can return nothing. It can say, okay, this record is invalid, let's just ignore this particular record. Or this particular line is something which we are not looking for, it can simply ignore that line. So, a mapper does not always have to generate at least a key value pair, not even one. It can completely choose to ignore the result and not generate any key value. Yes, that's correct, Peter. You are right. So, yes, yes. So, is everybody convinced that the answer to this has to be wrong? Is this okay, or do you need more explanations? I can explain again if you want. All right, should we move forward? All right. Next question is, by default, there is only one reducer in case of streaming job. Is that correct? So what happened when we ran our word count earlier in the Hadoop streaming? Did it generate one file or multiple files? If there are multiple reducer, that it will generate multiple files. If there are single reducer, it will generate a single file. Okay. So by default, there is only one reducer in case of streaming job, yes or no? Correct. The answer is yes. By default, there is a single reducer job, but it can be split by specifying the okay by specifying this particular variable in streaming. Okay. All right. A or B? What is the role of job tracker? A is executing MapReduce logic. B is delegating MapReduce logic. That's correct. All right. So let's take a break here and then come back after the break and continue from here. All right. Hi everybody, I'm back. So should we start now? All right. So there was a question from Anand. Let me just quickly answer that. So what he's saying that he's unable to download the courses. I'm unable to download the presentation from No Big Data. Can you please help? This will help me go through the documents. So let me just pick up our class. Okay, here let's take the case of first presentation. Okay, and here copy link address. Okay, so don't you see this page? You see the download button here, Anand? See the download button? Can't you download from there? All right, so yeah, you can download it from there. It's just that don't put it in public. All right, so question to all of you. The map logic is executed preferably on the nodes that have the required data. Is that statement yes or no? Map logic is executed preferably on the nodes that have required data. Alright, those who are answering with no, could you please put a reasoning? Okay, Dilsad and Pankaj, could you yes. So that's what it says, Pankaj. It says map logic is executed on the nodes that have required data preferably. Okay. Okay. The keyword here is preferably. So and now Dilshad, you're exactly what you're saying. Let me ask that thing to all. Yes. So the keyword is preferably. Okay. Here, the most important part. All right. Now, next question to all of you is this. All right. The map logic is always executed on the nodes that have required data. Instead of preferably, I have put always this time. Now, is that correct or wrong? Correct or wrong? Now, Dilshad and Pankaj. So Kamal, we are only talking about HDFS actually. When we say required data, we are actually pointing to HDFS only. Okay. All right. The answer is yes. It's wrong. Good. Next question to all of you. Where does Hadoop store the result of reducer? In HDFS or in local file system? So Hadoop, when we gave the output folder in our Hadoop this Hadoop command, when we were running the streaming job, so this output folder was in HDFS or is one in local file system? Did you try that? Correct. That was in HDFS. That's right. Where does Hadoop store the intermediate data, such as the output of map tasks? Is it in HDFS or local file system or in memory? Anybody? This is a little difficult question. So as we already talked about that when our map tasks will be generating the key value pairs and those will be sorted and then sent to the reducer. So this output of map tasks, where does it go? Does it go into HDFS or does it go into local file system or in memory? All right. So, I mean, please keep it in mind that Hadoop has been designed for petabytes of data when answering this question. All right, that's correct, Rohit. So, the output of map tasks is only stored in the disk. First, it's taken into a memory, which there is a circular queue in which all the map tasks output is kept and then purged to the disk. And from the disk, it's gathered and goes to the reducer task, and that's where the aggregation is happening. All right. It is not kept in HDFS, and the reason for that is that this data is intermediary. It's not required once the job has finished. Therefore, if this data is kept in HDFS, it's unnecessarily we'll have replication, we will have this, we will have that. Unnecessarily, we will have all this data lying in HDFS. Okay, that's the reason it is kept in the local file system. But before local file system, it is kept in the memory. In the memory, in the form of a circular queue. In the circular queue, The tasks are putting the data and then it's being consumed and kept in the local disk. All right. Yes, intermediary files will be visible to the local file system. That's correct, Anand. Generally, there is a TMP, there is a folder in TMP/TMP. That's where the data is generally gathered. Okay. Srini's question is local file system means yes. Local file system means the file system which is installed on C colon D colon on that machine or in slash somewhere. That's where it's kept temporarily. Yes, it is purged after the reduce phase has after this data has been sent to the reduce phase, it is purged. That's correct, Peter. Thank you. Sounds good to you? All right. So probably the last question. The whole of the HDFS block available on a node is fed to the mapper. Yes or no? Also put your reasoning. Okay? Yes, that's correct, Dilsad. All right. Peter, I did not get this. Peter is saying you can't grab a part of the block even if it isn't full. All right. Yes, but do you think the whole block is fed to our program? So when we talked about big.txt, what if big.txt had been bigger than the one block? As in, let's say, had it been 129 MB, and do you think the whole line will be in only one node? Will it not split into two? Could there be a possibility that a line is broken? I mean, the block's boundary of 128 MB reached in the middle of the file, in the middle of the line. Do it make sense? All right, let me try to explain now. So the input is split using input splits, and part of which is transferred to other mappers. All right. So when the so we will go into the details, but for now you can think of it as the data which is stored in HDFS. It has been ruthlessly divided into 128 MB. And when I say ruthless, it means it did not care whether it was in the middle of line, middle of paragraph, middle of the word, and in case of the Unicode characters, it may be in the middle of word or middle of letter actually, middle of each character, because there are multi-byte characters sometimes, and then it can be split. One character could be in two blocks. First half in first and second half in second. So question to you is that, okay, so does it make sense to, I mean, to assume that the whole line would be available to your mapper? Okay. Yes. So we'll go into this detail now after a quick overview of MapReduce in Java. All right. So first is why Java? Simple reason is it's a primary support. As we told you that even Hadoop streaming is written in Java. So the whole Hadoop is actually written in Java. So but but because of Hadoop streaming Java code, we are able to run any command as part of our job. Now, but the primary support in Hadoop is for Java. Okay. Sometimes you want to alter the behavior of MapReduce to a very large extent. All right. And that can be done only in Java. Lots of behavior could only be done using Java, but you can write wrappers around it and get it done using other programming language, but you will have to write the wrappers. Now, so the simple steps are to get up and running with Java is you download the Eclipse first and then create a Java project. In that Java project, add these libraries. All right, add these libraries. Okay, and change the compiler to 7 and change the Java compiler setting to 1.6. Okay, so here if you go, you can simply download the sample project from here, and then you can actually import the full project. Okay, you can import the project and also go through this 4 minutes video which I have prepared, in which you will understand what are the mistakes you are making. Okay, so it shows that you can import the project like this. All right, so in case you get stuck, just go over this video that you'll get your answers. Okay, for time being, I'll show you. Now, Pankaj's question is there any specific reason why we have taken this? All right, that's a very good point. I actually forgot to mention this. So, whenever you are building any program, whenever you're coding, you should keep your requirements really low. Okay, so if your program is compatible with the lowest version of the platform, that means your program will be run easily on many machines. Okay, so as a thumb rule, whether you are doing it for MapReduce or you are creating a mobile app, everywhere you keep the settings to the lowest possible. Okay, so when Java 6 was hot, we used to still write our code which was compatible with Java 4. Okay, so the idea is that whatever you do, you make sure that your program can be run by many people, not only the people who have this latest version. Okay, so that's the reason why we set it to so it's a good practice to keep your compiler settings really low. All right, so we are talking about this one. Okay, it's actually pretty straightforward. Once you download the project, all you have to do is import, and you go to existing one, browse to the project and click OK. And once that is done, clean the clean the library, because it will be referring to the libraries which are located on that file system. Okay, so you'll have to clean this and add the jars again from the given folder. Okay, so Pankaj's question is, if I have JDK7 and by default compiler will be JDK7, that's correct? Yes, by default the compiler will be in JDK7. Alright, so it says that these things do not exist. Let me just close all of these. Alright, now going back to the slides. Alright, so once you have Eclipse up and running, then you can start coding, and all you have to do is create three files. One is called driver, okay, other is called mapper, other is called reducer. Okay, so here's what you do. So once you install the Eclipse, create Java project, add the libraries, and change the JDK to 7, and then Java compiler to 1.6. So please note that if somebody is having Java 10 or Java 9 or Java 8, it can run your program. It has been compiled on the previous versions. But if somebody is having Java 7 and you have compiled your program in Java 8, it will not run. So compiler of Java 8 will not run the code compiled with Java 9. Okay. So older JVM cannot execute the newer Java bytes. Okay. So that is the reason why I generally keep this kind of compilation. And here in our case, this is doubly true because nobody executes MapReduce locally. Everybody has to schedule, after compiling, everybody has to ship it to the cluster. Also, and since Eclipse you are installing, you cannot install generally on the cluster. You always install Eclipse on your local machine. So Eclipse is on your local machine and cluster is somewhere else, and we need to ship your program. So whenever you are shipping the program, make sure that your program is compatible with lowest possible set of libraries and lowest possible dependencies. So this is called backward compatibility. All right. Now, the first step in the whole process is to create a mapper. Please note that here there is too much of you. It might look like a baggage to you. So we will talk about it. So first, you extend the mapper class, and then you give the name. You can give anything else also in place of this. And once you have extended, once you have said that I'm extending this mapper class, you say that I'm overriding a function called map. This function is from the parent class and we are overriding its behavior. And what does it do inside it? What it does is it says that words equal to value dot to string dot split, meaning this value which we have got in the arguments. So we got object and the argument, and this object is the byte offset. Okay, this object is the byte offset we are talking about. All right, how can I make it look a little smaller? All right, never mind. So it's like not line number but byte number. Okay, instead of counting lines, it's counting bytes because line number cannot be predictably correct. And the value you get is in this case, because we are trying to read a plain text file, the value will be each line of the plain text file. And this context is an interesting thing. Context is the object in which we will be pushing our data to. So context is something like a big bowl in which we are putting our key values, and it will be gone. Okay. So Hadoop will execute your map function by passing the byte count of the record of the line and the line actual line, and then an object in which you have to put your output. So what are we going to do here? From the input line, which is value, we are splitting it in by space and tabs, and whatever array of words we get, we iterate over the words and then output to context. We are writing to context. All right? Is that clear? Is the mapper clear to everyone? I know it's not clear. Okay. So, all right. Let me just. Okay. So there are a few things I left. I left these parts. What is the role of this? Okay. What is the role of this? This is a common problem. So instead of making your mapper open to any input or output, you enforce the type safety by saying that this particular mapper expects the key as object and value as string. Okay, and it plans to give out the data types in text and long writable. Okay, so basically we are saying that we want to output data in certain type safe manner with certain data types. That's what we are doing here. We are saying that our mapper will receive our mapper can receive the byte count only, which is an object, and our input line is of text format, and we will be giving out text format and a number. Remember, we are just printing word comma one, word comma one, and that's why it is long writable. That one is long writable. Okay. Also note that we are not using the standard classes from Java. For handling the text, we are not using string class of Java. Also, we are not using the int class of Java. Instead, we are saying that we are long writable. Okay. So long writable is a class, it's a wrapper class given by Hadoop to you so that it can handle the serialization and other semantics of the language. Okay, so for each of the basic data type, Hadoop has created these wrappers, and that's what we are supposed to use while writing MapReduce job. And while we are printing word comma one, what are we exactly doing here? We are wrapping it. Our word, what we are trying to do is instead of just printing word comma one, we are first wrapping the word in a box and printing that box. Okay, we are wrapping our word in the class called text and then printing that, and the value we are printing based on the argument. Okay, so the value also is a long writable. Okay, it's basically a wrapper, and that's what we're trying to do here. Anand is saying long is a numeric related data types, but the result set will have test as well. Yes, result set can have text as well. So here this text is this you see this is the input key and input value. These are the data types, and these are the data types of output key and output value. Is that what you're looking for, Anand? So Rohit's question is, where are exactly we are using this byte offset? The object key which we talked about, are we using it? The answer is no, we are not using it. But in some problems, we need the line number. Okay, line number, or you can say byte count. All right. So here's a question from Anand. So here long data type stores both numeric values and then text. No, it does not. It will only store, that's correct. That's your hypothesis is correct, because in general long will store only numeric values. Yes, that's correct. So this is our key. We are giving out this as the key and this is as our value. Okay. In tomorrow, if we want to output text instead of long, we can say text here. Okay. If we want to output key as an integer, we can write long writable. Okay. And in the second part, we could write text. So this says that our output key is going to be this. Our output value is going to be this. All right. All right. Now, Rohit's question is there a way to debug this code with sample data in Eclipse? Yes, I'll show you that. So that's where the test case will be used. So Kamal's question is, what if the data is sequential? What would be the input line? What does it mean? Sequential, what does it mean? Yeah. You mean binary? Yeah. All right. Now, once you have written, just let me know, Kamal, what do you mean by sequential? Okay, so in those cases, you will get an object. You will get a different objects here. Okay, I'll help you with that. So you can change the data type based on the input format. Okay, so right now it's only text, but these things can change when the when the different input formats are involved. All right. So now one thing which we wrote was the mapper, which gave out key values, key and value, and so on. Now we have to write a reducer. Reducer gets as an input key and the value, list of values, all the values aggregated together as a big list, and that's what we get as the input. And we are trying to write in the output as key and another value. So here it says that reducer will get text as the key, long writable as the value, and the output reducer can give is can be text, text as key, and the value will be long writable for output. And that's what reducer is doing. So what reducer does is it will iterate over the values, okay, and compute the sum. It will get all the values and compute the sum, and then print it in the output stream. You can see that here. That's what reduce is doing. Sounds good to you? All right. Is that clear to everyone? Any doubts on this? All right. Once we have written mapper and reducer, then is the time for stitching it together. To stitch it, we create a third class called stub driver. This stub driver is like a normal program. It has got the main method, and that is the entry point for your program. So in the main method, this driver will create an instance of job, and then that job will have a name. This is the name of the job, which will show you everywhere in the processes. And we pass some configuration value saying here is my name node, here is my data node, and or here is my resource manager. So this conf contains all those details. Now once we have done that, we can set the mapper, set the reducer, and also set the entry point. Okay, and also tell what key to expect, what value to expect, and all those details. Okay, so we are telling the job that hey, here is the mapper, here is the reducer, and this is my output key class. Okay, this is my output value class, this is my, okay, this is the map output class, this is the map output, uh, map output key and map output value. Okay, so what we are trying to do here is we are stitching the things together. We are basically creating a job definition telling that hey, this is my mapper, this is my reducer, this is the data types which is being printed by Hadoop in after mapper has finished, and then so that's what we are telling. Okay, and at the end of it, once everything is done, we are saying job dot wait for completion equals true, and this is where the whole process starts. This is where whole process starts. Okay, so and after that we say system dot exit because all of our work has finished. All right, once you are done with that, you have to export the jar. Okay, and then we copy this jar to the servers. You can use WinSCP to copy this jar to the servers. Alright, and then execute it like this. Let's try to do this now. Alright, so we have our step driver who is doing something. It has got the job definition, mapper reducer, output key, output values, and so on. Okay, this is my step driver. Once you import your project, the project which is given in the assignment, the code in the LMS, from there if you download this project and import it to your Eclipse, this is how it look like. Okay, and once that is done, what we can do is we can say file, export, jar file, and then save it somewhere. Let's say we call it Sandeep MR, and the name of the project is TRG2. Okay, all right. Did it create? Let me just try again. Export jar file trg2. This is where we had kept. Okay, so we can go to the file system where we exported it, and then yeah, this is what it is. Okay, so this we will import, copy to our servers. Okay, and the way we can copy in two ways. Please note, we can copy this file in two ways. One, we can take it to our HDFS using Hue, and from there we can download it locally. Let's do it that way. Okay, let's log in into Hue. Okay, so we'll do it in two step. And why am I doing it in two step? Because file SCP is not working for lots of us. Okay, so let's go into my folder. Ouch. So all right. Okay, so what is it that we are trying to do? We are trying to take the jar which we just created after compiling the code. When you export the code in Eclipse, it automatically compiles it. So we did not have to compile anything. All we have to do is upload it onto the server. Here is our HDFS. So we are putting it in HDFS, but our jar has to be local. Therefore, we will have to do that. Okay, let me upload. So it was in somewhere in downloads. Yes, and this one. Okay, so it is in my folder, in this folder. And if I want to copy it to local as in that machines, that nodes local file system. So we can say Hadoop fs minus copy to local, and this is the file system. All right, so you can see that. Okay, you can see that we have copied. Ouch, that was not supposed to do. This is sg.rsmr. All right, is everybody with me? So do you see Here it is. So okay, now I can see Hadoop, jar, and our program. It says that you have to provide the main class argument. And what is our main entry point? The driver class. Okay, this is our main entry point. Let's have a look at that. Okay, so there is no other way. So I can simply say step driver is in what package? It is in my package. So I can say my dot step driver. Now it's executing our program. Did you see that? It's executing our program. And where this line coming from? Here. This is the line that is being printed over there. So we are able to run this. It is just that it's asking for an input directory. And let's provide some input directory. Okay. So we are providing it the input directory, and we can provide it something like asgiri.sg.txt. This is our output folder. So both this input directory and output directory both are in HDFS. Okay. Now you can see that this has started running the process. All right. So it has successfully saved the output in my asgiri sg.txt. Let me refresh it. Okay, so you can see that it is a folder which contains two files. One is underscore success, which has 0 bytes, and then there is this data. You can see that it has computed the word counts using Java. So Dilshad is saying that can you also run the example with the Hadoop streaming? I keep getting error on that. Can you just copy the command which you are trying to do it on Hadoop streaming? I'll try the same thing. All right. Yeah. If you have the command which is failing for you, could you give it to me? I'll try running it right away. All right. Let's see what exactly is here. Okay. Let's try to run it like this. Okay. So if I go to my asgiri folder and try to see. Okay, so it says that this is my streaming. It says the mapper is not found. Oh, okay. So the command which we are talking about, this one, let me make it in a single line. Okay, let's make it first single line. Okay, like this, and like this. Okay, so I converted that into single line first. What does it say? It says that mycmd.sh does not exist. That's okay. All right. So first we have to create mycmd.sh. Okay. And in that we could say mycmd.sh, or we could say nano. Nano is the editor, and I could say here sed substitute space and tab. Okay. and I'm saying this, replace it by /n. Alright, that's what it does. So let's try to run chmod plus x mycmd.sh, and if you run echo hi, how are you? Okay, let's try to pass it to our mycmd.sh. It says, okay, now let's first test it. No, it did not work. Echo space or tab, any number of those should be replaced with /n. No, it did not work. Substitute -r. What was the command, by the way? Yeah, this is working. -r means regular expressions. Okay, now let me try to take this. What does it say? It doesn't have output folder. Okay, it has to have an output folder. Let me just create some arbitrary folder. It says that the input path does not exist. The input path does not exist. We'll have to say data mr and then it'll work. Sounds good? I think this time it's running. Okay. So now that it's running, so this is it clear? It says something about it's attempting to run this, and alright, it failed for some reason. Okay, so let's try to see what is it that we are trying to do. We are saying that Hadoop jar, this is my streaming jar, map task equals to 2, and input equal to this, and our ascii.word count is here. Okay, so why it has failed? Let's see why it has failed. Because we have, did it work? Did it take this mycmd.sh correctly? Okay, let's just try to put /mycmd.sh. So it says this output folder already exists. Let's just delete this. Hadoop fs -rm -r. Okay, so once we have deleted the output folder, we are running the same command again. Okay, let's see the status of our cluster, whether it's running or not running. What is the chmod command for? That is Shashi's question. So in Unix, you have to tell explicitly that this program is executable, this program is not executable. Because Unix does not infer the whether your program should be executed by the extension of the file. Here, you have to explicitly mark it executable. It says the job has failed. Why is the job failing? There must be some error somewhere we are doing. And let me just go through the command line clearly. Okay, it's Hadoop jar. This is our map streaming. These are the number of tasks which we are executing. Input is this. Oh, this is not something correct. Okay, only one file. It will again give the error in the input directory. What else could go wrong in this? All right. Hadoop jar this minus d this input is this, output could be, alright. Let's see what is happening on the server. Looks like this time it's running. Should give error now. Okay. Okay, now this time it is successful. It was because we were having an extra folder. Okay, so you can see that Hadoop fs minus ls has been, it has resulted in two parts. You can see that part 0 and part 1. Alright, Dilshad. Okay, file is there. Anand's question is that uh, in that command minus file is there. So we can create my cmd.sh. That's what we did. Yes, we need to make this mycmd.sh make available to all the nodes because it is our program. It is not something which exists. Okay, let me give you this code what we just ran. Okay, that will be easier for all of you. All right, sounds good to you? All right, so yes, we were able to run our MapReduce program by by writing it in Java. And there are many things that we need to know when we go into the details. Also, when we talk about adding multiple files as input, you can add as many files as you want using this particular arguments. So if you have some other file, you could say myfile.txt. So these are the files which you are adding in the input. Okay. All right. Sounds good to you? All right. There's a question from Dilsad. Question is, okay, let me put the corrected code. Yeah. All right. So question is, what does this set jar by class do? Set jar by class basically tells the entry point of this jar. Okay. So sometimes in some versions of jar program, you don't need to specify the you do not need to specify the driver program name. It will automatically figure out because of this. Okay, that's a part of kind of okay, so that's something which is configurable. All right, we're just giving the name to the jar, that's all. All right, so that was our simple mapper reducer for word count problem. Now when you are coding, when you're writing a program, when you're writing your code, no code is complete without a test code, without a test case. Test case means there was something input expected and there was something which came as the result. So the we need to always compare the expected with the actual. Okay, that's what we do as part of test case. So here we are trying to generate the output from the mapper, and whatever is the result, we are comparing that with our expected values. For example, here let me show you. If you see step test here, you can see step test here. We are saying first we set up. So this is basically MR unit is nothing but JUnit, an extension of JUnit. It has got couple of new classes as part of the JUnit. Now we first create the dummy mappers, dummy reducer, dummy driver. These are the dummy drivers. Okay. So and then inside the test mapper or test reducer or test driver, we will call these mapper and reducer which we have created above, so that can run this program can run on your desktop. It will run on your desktop. So you can see that we can basically go here and say run as and click on JUnit test. Okay, so this purposefully we have implemented this as fail. So the test cases which will fail will get this kind of error. The test cases which are successful will show that it has run perfectly. Let's take a look at this testing the mapper part. Okay, all we are doing is first we are creating input, and then after we have run the mapper driver, we are comparing mapper values. Okay, you see that assert equals this. So we basically compare how many values are there. So we are basically saying get the zero value, check if it is this, get 1 if it is, get 2 if it is test, because we are replacing this with nothing. Okay, so these are the ways you can actually test your MapReduce. Here I'm providing some input files by providing add input, add input. Once we have provided the sufficient number of key values, then we can run the MapReduce driver, and the output we can compare with whatever we want. We can see that we are comparing the output of comparing the size of the output with the hard coded values. So okay, so this is how you generally write a test case. All right, so that's how you will write the test case. And all right, now there's something very important which we want to discuss. So all of you try running this Java code, try running this MapReduce code at your own. You will discover that there are a lot of things which I talked today. You skip those parts. So you might have to go through this audio again, or you might have to go through that project configuration video to get it correct. All right. All right. So the Java map reduce is clear to everyone. We basically created three classes: driver, mapper, and reducer. In mapper, we created a function called map, in which we got the three parameters: input key, input value, and a context object in which we were putting the output. Similar was the case with reduce, just that the second argument of the reduce function was a big iterator. Big iterator as in all the values represented as if it's a sequence of lot of values. Okay, like a big array. All right. So does that sound okay with everybody? Now, Rohit's question is, how do we debug this kind of program? Now, one of the debugging, yeah, thank you, Rohit, for asking that question. Let me try to mention that. All right, so there are multiple level of debugging. Debugging means finding the bugs in your code, and there are multiple ways to get it done. First is first is run the MR unit test case stepwise. Okay, you could go here and say, let's say I'm trying to test my mapper. I'm putting a debug point here, and here I'm saying debug. Not this one, not this one. Okay, where was the debug command? Why it's only running? So we can say here debug as JUnit test. So it says that open the debug perspective. I say yes. Okay. Now you can see that it has stopped at the point which we had planned. So you can go over each and every values And as you go over, all the values which you want are displayed on the right hand side. Okay. Sounds good to you? Now, this is debugging of our MR unit code. Sometimes you want to debug in real time. That is something which is not possible. Okay, the stepwise debugging is not possible. But what you can do is you can write you can write in your Java code something like systemout.println. You can see that this is sysout.println. Now, once you see this system out.println, you can go to, once the job has finished, you can go to, not Ambari, you can go to Hue and you can go to job browser. Under job browser, is that mine? This is stream job. Okay. Okay. So you can see that. All right. Now, where did we make mistake? So last, this is the command which I ran. Okay. So I think I'm looking at wrong job. Let me run the job again and then check the output. Okay, this is the job which I ran earlier. Here it's this particular job. This is the job ID. Okay, so coming to it again, you can see that there are two things I'm printing here in the mapper, DDD and error. Okay, so let me try to find out where did these go. All right, now tasks. You can see there are two mappers and two reducers. Okay, so generally it comes here only. Since we have recently upgraded the job browser, alright, this is what we're trying to do. Are we actually printing it? So basically these things need to be printed into our std out and std error. and I'm not getting hold of the. All right, so this is my container, single logs. Nope. No, actually, task. Actually, the UI had changed a bit for this. That's why I'm having a little tough time. So there are map tasks, right? We need to figure out the logs for each of these map tasks. Okay, that is what I'm trying to do. Okay, so these are the single logs. Okay, that's not a problem. Now, yes, yeah, we have to go into the job and then go into the attempt. So every job has got an attempt, and every map task has got an attempt. I think it's coming or something. And I think it will take some time to come. Yeah. So now it is here. So Rohit, you can see that in the logs of the map task, there are a lot of DDs are printed, and these DDs are something which come from here. Okay. Okay. You can see that. And in case of error, you can see that error is being printed because here we have written system.err.print. So we are writing to error stream, we are writing to out stream. So this is another way of getting the debug done. So you can put in your code, if this is this is, then find out this. And I'm here, I mean, basically you can keep on printing out the debugging information using sysout, and in the logs you can locate this information. All right, was it clear or was it too confusing for you? All right, So that's pretty much for today. We will continue tomorrow from this point onwards. So tomorrow's session is very important. We will go into the details of the advanced operation. We will go into the details of these advanced operation. All right. Thank you very much. Have a good day. Bye bye. All right. Same time as today, Shashi. We'll start same time as today. So I have sent a detailed email with the time zones. Okay. So from India point of view, we are not changing the time. Okay. From India point of view, we are not changing the time. So you adjust your time accordingly. All right. Okay. Thank you very much. Bye bye.